So correlation versus causation. Causation is just like it sounds, it causes. So causation is when making a change in one variable causes the other to change. Correlation is when two things go up together, or as one increases, the other decreases. Remember, you can have a positive or negative correlation. So one example of this that you'll see very typically, and I just want you to look at the graph on this. So if you look, it says the number of ice cream cones sold and the number of reported shark attacks. So ice cream sold, as the number of ice creams are sold in a certain city or whatever, as this is going up, the number of shark attacks, not Shark Tank, sorry, shark attacks also goes up. So if you look at that, that's a pretty strong correlation. If I drew my trend line through that, it would touch a lot of those points, or they'd be really close. So this is a correlation, but it's not a causation. If I sold more ice cream cones, that really doesn't affect how many shark attacks happen. Yes, it's correlated because as ice creams are sold, it's probably warmer outside. Since it's warmer outside, people are probably getting in the water more. If you have more people in the water, then you have a higher chance of people getting shark attacks. So it doesn't directly cause. I can't say the number of ice cream cones causes more shark attacks. It's just they're correlated because as weather gets warmer, people buy more ice creams. As weather gets warmer, they get more in the water. So it's more it's more typical to have more shark attacks. So here's another one. If you look at curb weight, what they're talking about curb weight is just a car, the weight of a car with no cargo or occupants. So an empty car, so not including the people in it. So if you notice as the curb weight gets larger, so this one up here is almost 35, sorry, there's the bell for this morning. So almost 3,500. This one over here is like 6,000. If you look, it says gasoline consumption in miles per gallon. So as the weight of the car goes up, the gas that it consumes is going down. So you can see this is a negative correlation. If I drew a trend line, again, that's not a very good trend line, but a trend line is supposed to be as close to as many points as possible, touching as many points as possible, not really far off. I wouldn't want to say, oh, well, I can touch 3 points here and be really far off from that point. Just a reminder. So you can see there appears to be a strong negative correlation. As the weight of the car increases, the car's economy decreases. You might be tempted to say that making cars heavier causes them to consume more gasoline, but the trend you see may be due to larger cars having less efficient engines or poor aerodynamics. You cannot say that weight causes, so you cannot say that weight causes poor efficiency. There is always a huge debate that can happen between saying something causes the other, but increasing my weight does not cause, is not the only, you can also say only cause to make the gasoline go down. So the heavier the car, like it says, it could be poorer aerodynamics, it could have a less efficient engine because it has to power the heavier thing. So it has to directly cause. So if you think about, like the other day we were doing our the steps back. So every time we took steps back, the time increased. The number of steps back caused the so the number of steps back caused the time to increase because there was larger distance between everybody. So that is a correlation and a causation. So let's write a couple of those examples. So ice cream, oops, I'm spelling ice cream wrong. So ice cream, oh my gosh, I cannot spell, I'm sorry. Does not cause shark attacks. So they are correlated, but not causation. Okay, the next example we talked about is we said that car weight does not cause lower gas mileage. So that's again correlated, not causation. The Twizzler activity, that's a really good one. The number of bites caused the length to decrease. So that is correlation and causation, because it caused the other. Like cause and effect, you can think of cause and effect. So here's two more examples. If you look at height and your shoe size, so height, these are correlated. Usually the taller you are, the larger your shoe size is. But if you change your height, say some terrible accident happens, and you break your legs and you have to, like they have to do something to them, or if you have to have your legs amputated or something, causing or changing that height, your height, does not change your shoe size. They are definitely correlated, but they're not a causation. You cannot say that changing your height causes your shoe size to change. Yes, they're correlated. The taller you are, the higher or the larger your shoe size is, but you cannot say that they are a causation. So that's another example of correlated but not doesn't have causation. This one, I haven't shown you this example, but let me talk about it real quick. So the number of marbles, and this is talking about number of marbles that you put in a cup, and then the distance from the table to the top of the cup. So if I attached a cup to a table, and then I added, like using string or whatever, and I added more marbles, as you add more marbles, the distance is going to increase. So that rubber band or that string is going to get stretched out, and it's going to get further and further away. So this one is a causation because the number of marbles is causing that distance to go up. So that's what correlation and causation are. I have a couple of funny examples. Let me find it. So just bear with me here. Some of these are a little weird, but trying to get you to remember how to remember. So a recent survey shows that 100% of people who drink water die. That's a fact. So everyone drinks water, or anybody that does drink water, eventually, sadly, you are going to die. I don't know of anyone that has lived forever and ever and ever. This one, I don't want to do that one. It's along the same lines. So when studies find an association between two things, it does not mean one thing caused the other. Here's some weird examples. Number of people, so you can see at the top, number of people who drowned by falling into a pool, and films Nicolas Cage appeared in. If you look, goes up, goes down. They're pretty close together, so there is some correlation here, but there is no way the number of people who drown causes films, or the number of films Nicolas Cage appeared in does not cause the number of people drowned by falling in. This one talks about per capita cheese, so how many people eat cheese, and the number of people who died becoming tangled in their bed sheets, that does not cause anything. That the age of Miss America and the murders by hot vapors, divorce rate in Maine, and the per capita consumption of margarine. That's just butter if you don't know what margarine is. So divorce does not cause, or the more people that eat margarine do not cause Maine. They just appear to be correlated. So that's causation and correlation. There is usually a debate that comes along with it. If you're talking about study, like if the number of hours I study for a test will cause your grade on the test to go up. Your attendance, if you're absent a lot, it can cause your grade to be lower in the class. So you just have to decide, can you put the word cause? Like, do ice cream sales cause shark attacks? No, they do not. So it would be correlated but not causation.